Geotechnical Engineering, Part A, Soil Mechanics, Chapter 8, Seepage. Let's solve an interesting problem in 1D seepage in soil in a two-layer soil. In this problem, we are provided with the two layers of soil. So this is soil 1 and this is soil B with the same cross-sectional area, and this is the interface between two layers. If we have a downward seepage in only k direction, so our problem is 1D seepage, we want to calculate uxx at the interface. It's not interface, it's we want to calculate water pressure in a line of xx, which is located 0.25 meters from our base, and it's just located in soil 1. If A1 is equal to A2, both cross-sectional areas are the same, and K1, the hydraulic conductivity in soil 1 is provided to be 1 times 10 to negative 5 meter per second, and K2 is 1/2 times of K1. If you remember the seepage equation, so this is the seepage equation in 1D, like Kz times d squared h over dz squared equal to 0. You can replace the partial derivation with just d over d. And if you solve this equation, it just gives you dh over dz is equal to c1. We do know c1 is I. If you just integrate it once more and just get h water head is equal to c1 times z height of water constant plus the second constant from the second integration, and it just gives you c1 times z plus c2, and we do know our c1 is definitely our hydraulic. So the equation for 1D seepage in z direction is equal to Iz plus C2. So if we do know this is the equation of seepage in 1D z direction, and we just based off the equation we do know in 1D seepage variation of water head is linear with respect to seepage direction. So this is the seepage direction from higher head of water to the lower head of water. Definitely this is the direction of movement. The variation is just a linear change in 1D seepage. So if that's the case, let's go by point A, C, E, and D. Let's start with the point C, which is in start of soil 1. H of C is equal to C1Z, which is I times Z plus C2, and Z is, this is our base. We just locate our base at the lower water head. So this is lower head. Then our Z is 0.25 plus 0.35, that's 0.6 meters, and all units are based on meters. So it just gives us a H of C is equal to the pressure. This is the amount of pressure on top of point C. This is the pressure on the top of point C, which is 0.6 meters, which is the pressure of water above point C. And also Z, which is the datum from your base, which is 0.35 plus 0.25, and gives you a total head of C is equal to 0.6 plus 0.6 is equal to 1.2 meters. So this is our first equation, which gives us 0.6 times Z times C1, which is I. 6 times C1 plus C2 is equal to total head of point C, which is 1.2. That's our first equation. this one, and just let's move to end of last layer. So this is soil 2. Let's see what do we have in terms of HDs. Feet 3 times Z plus C4, because we are just changing from soil 1 to soil 2, and our constant are changing, so two new constant. So HD is, if you just look at point D comparison to B, there is a this much amount of water on top of point D. If you want to measure point, easily go here and just measure it with height of water from the lower part, and it just gives you 0.1 meters of water head on top of point B. And also from datum, you need to climb down the same amount of height. This time that's for our datum. It just gives us a total of zero for total water head for H at D. And again, this part is from the pressure of water. The positive part and negative part is just comes from the measurement from our datum, which is climb down to D. So in that case, if you jot down the second equation, it just gives you Z, which is a 8.1, C 3 times Z plus C4 goes to 0. That's our second equation. And if we just jot down the equation for sharing boundary line equation, or the interface of two soils over here, and can easily write the first part in soil bond, so that's C1 times 0.2, which is the height of the interface is 0.2 from the base, 0.2 meters times C1 plus C2, because we are standing soil 1, and you can also jot down the equation also based off soil 2. Again, just the constant are changing, it just goes by the C3 times the same amount of height from the base, which is 0.2, as the interface stands at the same location from the base, plus C4. And this is our third equation. And also at the same time, we do know Q1 is equal to Q2. The same discharge passes through all layers, both layers, and that's equal to K1 I1 times A1. You can easily cancel out these two, and C1 is I1 and C3 is I2. So based off problem statement, K1 is 10 to negative 5 times I1, which is a C1, is equal to 2.5 times 10 to negative 5 times C3, which is our I2. And it just gives us the last equation, which is C1 is equal to 2.5 times C3. Then if we just jot down all the equation, we can create a a system with 4 equations and 4 unknowns. And if you solve this system of equation, it just gives you constant which we are looking for. So this is a C1 is equal to 2.3 something, C2 is a negative 18, C3.92, and C4.092. I just provide you with the link to solve the 4 unknown, and if you can solve it with different methods, also elimination methods. To most single calculator are just solving 3 equation, 3 unknown. You need to eliminate it if you want to do it by hand, and more advanced calculator just solve it. And you can also go to this link and solve it like online and get the constant like C1, C2, C3, and so it just gives you, and I just jot it down with 4 digits to get an accurate answer for our problem. So as soon as we have C1, C2, C3, C4, we can easily replace that in H head of water at XX line XX is C1 from solid 1. That's C1 times Z plus C2. And C1 is just, if you read off C1 is, read out C1 is 2.3077 times Z, which is 25. That's our Z from the base point 25, XX height from base, plus a C2, which is again point negative 0.1846. And if you do so, it just gives you the head of water at the line XX is equal to 0.392. And for calculation of water pressure, just HXX minus ZXX times gamma of water, it just gives you the UXX, which is 1.2 kilonewton per meter squared. And this part is HXX goes to 2 part, 8.25 from the datum, which is the height of water from the base, distance from the base, our base to line XX. And the other part is just the pressure of water, which you can easily see comes from here. So a part of pressure plus a part of datum, it just gives us the head of water. Final answer is UXX is 1.42 kilonewton per meter squared. We solve this problem with two other methods which are both interesting and easier from the classical methods. Uh, can follow us to see how we can solve it easier. Thank you. See you next videos.